Okay, so we're wrapping up completing the square with a really nasty complete the square. I mean, this thing's got fractions in it that don't even have, I mean, the common denominator of 3, 5, and 4, what is it, 60? Blech. So this is not an easy one. So if you can do this, I'm not going to be able to stump you with completing the square. So let's do it one step at a time. We'll complete the square. All right, what's the first thing we do? Usually we want to get rid of the constant. So I'm going to move the constant to the other side of the equation. It becomes a positive. Out the a term. So 2/3 of x squared. Then I got to figure what is 3/5 with a 2/3 factored out of it. I'm actually going to use scrap paper for that. I don't know what it is off the top of my head, but I know that it's actually whatever 3/5 divided by 2/3 is. So how do you divide in fraction land? You times by the reciprocal. So that's going to be 9/10. So there we go. I know then that this is 9/10 of x. There, I factored out the a term. Okay, what's the next thing you do when you complete the square? Well, the next thing is the actual completing of the square. I would like to find whatever goes in there to complete the perfect square trinomial. And I actually know it's half of this number squared. I think I better go back to the scrap paper. What's half of 9/10? Remember, of means times in math. And then squared. Well, let's see. Half of 9/10 would be 9/20 squared, which is 81/400. I told you this one was going to be ugly. So I am adding 80, whoops, that's not a squared. Get rid of that. I'm adding 81/400 to my bracket. But remember, I have to add or balance it out by adding the same thing on this side. But remember, I didn't really add 81/400. I added 2/3 of 81/400. Back to the scrap paper. What is 2/3 of 81/400? Oh boy. Okay, 2 goes into 400 200 times. 3 goes into 81 27 times. There it is. I actually added 27/200. Okay, what's the next step? Well, I can actually now change this to the perfect square that I know that it is. It is x minus, and the thing that goes here is just the square root of that, which is 9/20 all squared. Phew. Now, remember that I got to actually make this side one number. And back to the scrap paper. How do you add fractions? You need a common denominator. So the common denominator of 4 and 200 is 200. So that's 50/200 plus 27/200. I think I got it. It's 77/200. Oh boy. All right, what's next? Next, I'm in the stage where I can now isolate for x. I can solve this thing. I've completed the square, and now I got to get x isolated. So I have to get rid of 2/3, get rid of squared, and get rid of negative 9/20 in that order. So the first thing to do is to get rid of 2/3. So I'm going to take, I need more scrap paper here. Hang on. I need to take the 77/200 on this side and divide it by 2/3, which is like saying 77/200 times 3/2. And I'm afraid that doesn't simplify any. So I actually have to figure out that 2 times 200 is 400. And 3 times 77 is 231. So there we go. So now I have 231 over 400 equals x minus 9/20 all squared. All right, what's the next step in my quest to simplify for x or to solve for x? I got to get rid of the squared. So I square root both sides, and remember there's a little trick to this. When you square root both sides, you have to consider the potential that there is a positive or a negative answer. Oh, we're getting close. I can feel it. So now from there, I'm going to add the 9/20 to the other side. But you know what I notice here? I notice that this denominator actually is a perfect square, so I can just square root it. And then, hey, wait a minute. This is a common denominator, so I can make it as simple as I want, simple as I can. And that's about as simple as this answer gets without going to my calculator. And if I needed to, if say I wanted this as decimals, this is the exact answer, 9 plus the square root of 231 divided by 20, and 9 minus the square root of 231 divided by 20. But if I wanted a decimal approximation, I'd just go to my calculator. Here's calculator. Can you guys see the calculator? Okay, erase all that. And I would open a bracket 9 plus the square root of 231, divide 20. So I get 1.2, I'll say 1.21 approximately. That's approximately. And the other answer is, what if I use the minus? So here, I'll save some button punching. Did you guys know that your calculator can do this? You take the entry, and then you just go back and make it a minus. Oh, isn't that sweet? And then there you go. And you get negative 0.3. And I'll say again 0.31. So there's my two answers in decimal form. And of course, the other way I could have found these answers is to just run this whole equation here through a graphing calculator and get the actual roots, which again would be these approximate answers. But there you go. Like I said, putting that whole thing on the screen there, putting it all in perspective, that is as difficult as complete the square would ever be. Now, I'm going to do something else with this. If you can follow all these steps with numbers, you should be able to follow it with algebra. I'm going to do all the same steps I just did to the numbers, but I'm going to do them just with the symbols. This is fun. Watch this. Okay, what was the first step? We moved the constant to the other side, and we factored out an a. If I factor an a out of a bx, I get b over ax. So there, that took care of this step. What did I do in this step? Well, I completed the square. So what would go in here to make this a perfect square trinomial? Well, what would go in there would be half of this squared. And half of b over a is b over 2a. b over 2a squared is b squared over 4a squared. Now remember, I didn't really add just this to the equation. I added a times this. And a times this thing would just cancel the squared, because the a on the top would cancel one of the a's on the bottom. So this side of the equation gets a b squared over a 4a. And don't forget, there was still already a minus c there. Now on the next step, remember what I did is I took these two things in the constant and I combined them. Well, I'm going to do that again. What's the common denominator of 1 and 4a? Well, it's 4a, but that means that I have to times the top by the same thing the bottom was. So it's 4ac minus from b squared. So that becomes that. And while I'm at it, I might as well turn this into the perfect square that I wanted it to be. And the perfect square is always half, or the square root of this term. So that's b over 2a, and that's an x. All right, starting to take shape. What was the next thing I did? Oh yeah, I got rid of a. So I'm going to divide this side of the equation by a, which just puts another a onto this term here, because if you divide by an a, you times by 1 over a, so that becomes a squared. So now I have this. All right, what did I do in the next step? Oh yeah, I square rooted both sides. So this side becomes this, and this side becomes plus or minus the square roots of b squared minus 4ac over 4a squared. And at this point I noticed, hey, wait a minute, this thing here actually is a perfect square, so I can just leave the plus or minus on the top, and the bottom becomes 2a. And I also noticed then that, wait a minute, I have to move this to the other side of the equation, but they have a common denominator, so my final answer here is minus b plus or minus the square roots of b squared minus 4ac all over 2a. And this rather nasty looking thing is called the quadratic formula. And from now on, if you don't feel like factoring, if you don't want to complete the square, as long as you can look at a quadratic equation and figure out its a number, its b number, and its c number, you can run them through this formula, and it'll always give you the solutions for x. And this is where it comes from. We just derived the formula. So thanks for watching, everybody, and don't drink and derive.